Hi everybody. So just now we have finished with laws of refractions and laws of reflections. Now we are going to discuss one new phenomenon is what we call as interference. Alright. So how to get interference patterns when two lights superimpose each other, when two lights aid out, alright, or when two lights compare each other. Okay, so this is what we have. So what we are going to study now is about combination of two waves, alright, and how two lights combine each other. And this is done in class 11, chapter number last chapter, that is chapter number 15. How sound waves, not exactly a light, how wave, or that is sound wave, interfere each others or combine each others. And then it is something like we use what we call as a superposition principles. Superposition principles. So what we get is we get the interference patterns of a light by using what we call as a superposition principle. So superposition principle is a principle under which two waves combine each others. Alright, so this is what we are going to do, and so we are going to do what we call as interference. How we get interference? We get interference by adding up or by adding two waves. Alright, so before I before I do interference or addition of two waves, I would like to discuss what we call as two different waves or two different sources. We are going to discuss what we call as coherent waves or coherent source, or incoherent wave or incoherent source. Alright, coherent waves, it is there on the board, coherent sources or waves, incoherent sources or waves. So what do we mean by coherent wave or coherent source? So what do we mean by incoherent waves? So whenever we talk about waves, just now I told I'm going to combine two waves. So you could have asked yourself, what exactly is going to combine? What exactly is going to combine? So when we discuss a wave, we talk about displacement. We call what we call as displacements. So displacement is nothing but height. Alright? Whenever we talk about wave, there is an oscillations. Alright? So displacement is the height of an oscillation at any given instant of time. Alright? So this is what we have. So normally when we talk about a wave, so wave is represented by this equation. This is a simple equation which represents wave oscillations. Wave oscillations. So Y is what we call as displacements. So Y is along Y oscillation is taking place. Along Y oscillation is taking place. Along Y oscillation is taking place. What is A? A is amplitude. What is amplitude? Amplitude is maximum displacements. Amplitude is maximum displacements. And cos is a periodic functions. Cos is what we call as periodic functions. Why? Because it is oscillating. And omega is angular frequency. And t is any instant of times. T is instant times. This is what we have. So what that displacement is going to combine. Alright, so these are the things that you should keep in mind. Again, we have a phase, alright, that we will discuss later. So now I would like to define what is coherent waves. So I say that two waves are said to be coherent. Two waves are said to be coherent. Alright, if I have a single frequency, if lights or waves of a single frequency or a same frequency, single or the same are equals. alright, and equal wavelength, equal amplitude, and constant phase. These are very important terms. So I say that two waves are said to be coherent if the frequencies of waves are same, amplitudes are equals, and then the phase difference remain constant at any given time. Phase difference, this is a phase constant, alright, or phase difference is constant. Phase difference is constant. Phase difference is constant. And this kind of wave is what we call as a coherent wave. So normally we say that if the phase doesn't change with times, if a phase remains constant with time, then we call it as a coherent wave. So what is incoherent waves? If a phase doesn't change with time, if a phase difference changes with times, if a phase difference between the two waves changes with time at any given point is what we call as incoherent waves. So this is what we have, coherent, incoherence. So we are going to discuss only coherent part. It is only the coherent that gives interference patterns. It is only coherent part or coherent wave which gives interference patterns. Interference patterns. So this is what I have. Now this is the picture which tells you what exactly is coherent and what exactly is incoherent. So you see, alright, the frequencies are same, the amplitudes are equals, and the phase are changed. Phase means angle between. Alright, this is incoherent. That is random. Right? This is not randoms or same patterns. Alright, I'll give you another example. Alright, this is I have here. This is incoherent light. Why? Because we have a different wavelength or different frequency. So the different frequencies, that means it is sure that it is going to be incoherent, right? So incoherent light with different wavelengths and different phase. Phase is going to, angles is going to change with times, and then frequencies also change, is different. There is no single frequency or a single wavelength. Now this is what we call as monochromatic but incoherence. Why? Monochromatic but incoherent means same wavelength but different phase. Look at here, you have a wavelengths are equal but phase are different. Phase is different means at some time, at particular point, this wave is at a cross point and this is at the top point. So that means this is a phase is changing with times. Phase is changing with times. Alright. So this is the monochromatic but incoherent. Why? While here the single frequency, however, phase is changing with times. Now this is what we have. Coherent lights. Same wavelength, same phase. Look at here. The phase doesn't change. Every time this point cross. Every point this is top, right? So this is what we have. Alright. So now I have explained you what is coherent and what is incoherence. Alright. Now I would like to discuss what is interference. How you combine? How are we going to combine two waves? Alright. How are we going to combine two waves? Alright. How to combine two waves or three waves, whatever, right? So whenever we talk about combining wave, what exactly we are going to combine is just adding what? Adding its displacements. Adding its displacement. We are going to combine its displacements. So now look at here, I'll give you an example. This is the textbook diagram. Alright. So I'm going to produce a two-coherent wave. How can we produce a two-coherent wave? Look at here. I just go up and I disturb water coherently. When I disturb water coherently, that means I'm going to produce a two waves. One from S1, another from S2. when these two waves goes away and then they combine at point P. When they combine at point P, the displacement of two waves are going to combine. What is going to do? Displacement of, or I say displacement of S1 and displacement of S2 combined at P. And then we are going to see, right? Alright, this is what we are going to get. And alright, this is how we are going to get interference patterns, or how are we going to add up. Alright, so I'll give you another diagram. So this is what we are going to get it. So I just go on and coincidentally disturb the waters, and this is how it goes away and they interfere each other, and this is the diagram which we have. Alright, this is the diagram which we have. Now what I'm going to do is, at the point P, look at here. So at point P, alright, S1 P is equal to S2 P. These two are equal distance. I say S1 and S2 of equal distance from P. Since this coincidentally I'm going to disturb, alright, and at this point at P, wave from S1 combined with wave from S2. Alright, so that means, look at here, I'm going to say displacement. What is displacement at P? By due to, let's say due to S1 is given by Y1 is equal to A cos omega t, and displacement at P due to S2 is given by A cos omega t. Why? The reason is that equal distance. The reason is that S1P is equal to S2P. This is the reason, right? So now I'm going to add up. When I'm going to add up, I'm going to add the two displacements. Alright? Then addition is what we call as a superposition principle. So by superposition principle, I just write here by superposition principle, what I'm going to do is equal to 1 plus. This is how y1 is displacement at point P due to S1. Y2 is a displacement at P due to S2. Alright. So therefore, what is y1's? A cos omega t. What is y2? A cos omega t. Alright. Then what I'm going to get is this is equal to 2A cos omega. This is, and now look at here, this is amplitude. Alright, we all knew that, look at here, we all knew the intensity is what we define as proportional to scale of amplitude. Intensity is proportional to the scale of amplitudes. So amplitude defines intensity. And how it relates, and then intensity is proportional to the scale of amplitude. So therefore this is going to be this. Now when I say, what about the resultant amplitude? This is a resultant displacement, this is a resultant displacement. This is a resultant displacement. And now resultant intensity is going to be resultant intensity is going to be I, which is equal to 2a, right? 2a means proportional to 4a square cos 2 omega t. Alright, so this is what we call as 4I naught cos. Alright, and so there's no nothing like that. So this is what we have. This is the amplitude, this is the intensity. So intensity at this point is going to be 4 times the intensity of 2 waves. Alright, this is what we call as intensity at P is 4 times intensity due to each light. So intensity is 4 times. This is what we call as constructive interference. 2 waves interfere constructively. So I say here, what is the path difference? So I say a path difference, that is S2p minus S1p is going to be 0. Alright. Then 2 wave interfere constructively, and this is what we call as constructive interference. This is what we call as constructive interference. This is what we define as constructive interference. This is what we define as constructive interference. Constructive interference, where intensity is 4 times. This is bright. This is what we call as a bright, very bright. For light is going to be bright, and for wave it is the intensity is going to be 4 times. All right. So now, what I'm going to do is I'm going to discuss. This is what we have. This is what we have. So for 0 path difference at point P, crust is going to combine with the crust. Crust is going to combine with the crust, and you are going to get what we call as. All right. This is what we get, and intensity is 4 times. Intensity is 4 times intensity of individuals. This has intensity I naught, this has intensity I naught. So resultant intensity is 4 times. This is what we call as constructive interference. Now we would like to discuss wave interference of wave using path difference. We will discuss in a 2-way using a path difference and phase difference. First we will discuss a path difference using a path difference concept and phase difference concept. So both are same. So let's look at here first path difference. Path difference. So first is done. If a path difference is 0, it is constructive interference, right? This is what we call as constructive interference. Constructive interference. So now look at here, the second part is that S1Q, that means wave from S1 and S2 combine at Q, wave from S1 and S, right? Wave from S1 and S2 combine at Q. Alright, they superimpose what we call as superpositions, right? And then what is the distance? Alright, what is the distance? I say S1Q is equal to 7 wavelength. Look at here, I'll tell you how it is a 7 wavelength. 1 wavelength, 2, 3, 4, 5, 6, 7. This is the same wavelength. And then S2Q, and the displacement at Q is going to be Y1 is going to be A cos omega t. Now next is at Q. This is how many? We'll just count. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a 9 wavelengths. Distance is 9 wavelengths. What is the displacement at these points? So displacement at this point is going to be, displacement at Q is going to be A cos omega t minus how many pi's? What is the path difference? I'll see here what is the path difference. Path difference, I'll explain you this. Otherwise I can state right, but then just for explanation I will write this. Path difference is equal to S2p minus S1p, which is equal to 2 lambda. 2 lambda is corresponding to 4 pi phase. So look at here, I'll explain you why it is minus 4 pi. So from this wave, it will reach Q 4 pi later. Again, I'm explaining you. From S2 will reach Q 4 pi later. Alright. However, you know when we talk about wave, alright, whether it is a 4 pi later or 4 pi earlier, the displacement will be same. This is what we call as periodic functions. This is done in mathematics as well as in physics in class 11. So this is equal to this. Alright. So now what is the resultant displacement? Resultant displacement is going to be resultant displacement y is equal to y1 plus y2. Just A dot 2A cos omega t. This is and amplitude is what? Resultant amplitude. Resultant amplitude is going to be 2A. What about intensity? I mean resultant intensity. I naught. So this is what we call as constructive interference. Two waves interfere constructively. This is what we call as constructive interference. This is what we call as constructive interference. When a path difference is 2 lambda. I'll just put here that. Path difference is 2 lambda. Okay, now next, this is path difference 2 lambda. Now let's say path difference is odd, right? Fraction, right? So I'll rub this again. Again, I just said S1, wave from S1 and S2 combine at point R. Let's say point R. Okay, now from S1's ray travel distance, S1P is going to be 9.75. This is the wavelength, this is the distance. Look at here, I'll tell you how it is 9.75. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 75. Alright. This is S1. And then wave from S2, this is from S1, wave from S2 reach at so this is R, right? 2 is going to be how much? 7.25. How many 7.25? 1, 2, 3, 4, 5, 6. And then 1. Alright. 1. Like this is 1. Let's say this is here. 1 or 1, 2, 3, 4, 5, 6, 7, 2.5. 7. This is half. This is half. This is 0.25. Alright. So total distance is going to be 7.25. This is 7.25. Now we will say this is there in your textbook. Diagram is there in textbook. You see diagram properly in textbook. And now what is the path difference? This is the path difference. So path difference is going to be S2P S2R minus S1R, which is going to be 7.25 minus 9.75, which is equal to 2.5 lambda. This is lambda, 2.5 lambda. So path difference is 2.5 lambda, minus 2.5 lambda. Path difference is minus 2.5 lambda. Now this is the path difference. Now what is the displacement? Displacement at point R due to S1 is going to be S1 displacement. This is going to be A cos omega t. And what about displacements at point R due to S2 is going to be A cos omega t. Now look at here. From the wave from S2 will reach R earlier than wave from S1. So this is going to be plus. Alright. Earlier is going to be plus. Later is going to be minus. So plus by how many, right? This is going to be 5 pi. 4 pi is here, right here, right? For your understanding, I would like to write here is that one wavelength is corresponding to 2 pi phase. One wavelength is corresponding to 2 pi phase. So therefore, 2 wavelength is corresponding to the 4 pi. Then 2.5 wavelength is corresponding to 5 phase. Alright? So therefore, look at here. And then I say this y2 is going to be minus A cos omega t. Why? Because this is odd. Alright. 5 pi. So therefore, this is what this is done in class 11. Right? So this is displacement from this side. Then this is from S2. And what about S1? S1 it is going to be A cos omega t. Now what about resultant displacement now? Resultant displacement is alright. So this is equal to A cos omega t minus A cos omega t. Displacement is 0. So the displacement is 0 here. I write here displacement 0 here. If a displacement is 0, then what about intensity? Intensity must be 0. Intensity must be 0. If displacement is 0, I just write here if y is equal to 0, which implies intensity is 0. And this is what we call as two waves interferes destructively, and this is what we call as destructive interference. This is what we call as destructive interference. So this is all about as far as a path difference is concerned. Alright, so I will summarize for a path difference. So just to summarize, if a path difference is equal to n lambda, where n is equal to 0, plus minus 1, plus minus 2, plus number 3 is, then intensity is 4 times I naught, and this is what we call as constructive interference. Alright, and if a path difference is n plus 1 by 2 lambda, where n is equal to 0, plus minus 1, plus minus 2, plus minus 3, and this is what we call as destructive interference. Alright, so I have some diagram. So this is what I have. This is a constructive interference. Why? Because path difference is 2 lambda. This is destructive interference. Path difference is minus 2.5 lambda. So this is what we call a destructive interference. So now I have here. So this is a path difference is 0 constructive. This path difference could be n lambda. This is also n lambda. So we get constructive interference. This is how we get it. How two displacement combine. So here, when you combine here, this is the valley, this is a mountain, or this is a crust, this is a top. So when they combine each other, they cancel each other, you get 0 intensity. This is what 0 intensity. What about here? Crust is going to combine the crust, so you get bigger wave. And this intensity is 4 times its intensity. This intensity is 4 times its intensity. Alright. So now, I would like to do in terms of phase difference. Let's say that wave from S1 and S2, I would like to do in terms of phase difference. We are done with our path difference. Now we'll do in terms of phase difference. So I see a light from S1 and S2, combined at let's say point P with the phase difference phi. This is a phase difference. Alright, so this is something like this. Alright, this line from S1 and S2 combined at Q with some phase difference, and I say a phase difference is equal to phi. This is how it goes. So, if phase difference is phi, then displacement at the point P due to S1 is going to be displacement at the point P due to S1 is going to be displacement at point at P due to S1 is going to be, let's say, A cos omega t. Now again I say that line from S2 combined with S1 and then displacement at point P due to S2 is going to be y2, and since the phase difference is, let's say this is phi, this is a phase difference. Now I'm going to combine two waves using a superposition principles. So So additional wave, so the resultant wave is going to be, resultant displacement is going to be, y is going to be y1 plus y2. y1 plus y2, and y1 plus y2, that means this y is equal to a cos omega t plus a cos omega t plus phi. And this is the trigonometry identity. That is, if I write it on a board, I think you have done this in a lower class, that cos A plus cos B is equal to 2 cos A plus B divided by 2 cos A minus B divided by 2. This is done in a lower class. So applying this identity, I am going to get this is equal to 2A cos 5 by 2, alright, and then multiplied by cos omega by 2 plus, right. This is the resultant wave. This is the resultant amplitude. I am going to write here resultant amplitude, very important, right. Y is equal to 2A cos 5 by 2 cos omega t 5 by 2. This is the resultant displacement. Alright. Now I am going to subtract this term. This is amplitude. Now this is going to become amplitude. This is amplitude. This is amplitude. Alright. This is amplitude. So I just say amplitude at any point is going to be this. Alright. So amplitude at any point, so therefore amplitude is defined by what? Amplitude is defined by a phase difference. Why phi is a phase difference? Alright, since the phi is a phase difference, amplitude is defined by a phase difference. Alright, again I am going to write amplitude is defined by phase difference. Amplitude is defined by a phase difference. Alright, so what is going to be amplitude? So that is amplitude. And what about intensity? I just say intensity is going to be a scale of amplitude. Alright, proportional to scale of amplitude. So this is going to become whole square. This is 4A cos 2 5 by 2, which is equal to I is equal to 4 I naught cos square 5 by 2. This is the resultant intensity. This is how the resultant intensity is defined. I is equal to 4 I naught cos square 5 by 2. This is intensity. Right here. Again, I write this equation is very, very important equations. I is equal to 4 I naught cos square 5 by 2. This is intensity, resultant intensity. I am going to write resultant intensity. Alright, now if it is a resultant intensity, then now I am going to put a phase difference. Now I am going to put a phase difference. Now if a phase difference, if a phi is equal to, let's say, let's say 0, 2 pi, 4 pi, 6 pi, then very important, then I is going to be 4 I naught. Why? Because this is going to be 1. Cos 2 pi is going to be 1. Alright, this is all going to be 1. 0, all going to be cos square 5 by 2 is going to be 1. So this is what we call for constructive interference. This is what we call constructive interference. This is for constructive interference. Now condition is that phase difference is equal to 2n pi, and this is what we call as even multiple of pi, where n is equal to 0, plus minus 1, plus minus 2, plus minus 3. Now next is, now if I use value of a pi, which is equal to, if I say if phi is equal to pi, 3 pi, 5 pi, so on, then cos square 5 by 2 is going to become 0, then this is going to become 0, therefore I is going to become 0. So this is what we call as destructive interference. Destructive interference. Alright. So this is odd multiple. That I would like to write here. This condition is that this is equal to n pi, where n is equal to 1, 3, 5, so on. This is what we call as odd multiple of pi. We get destructive interference. Alright. Now we are done with the both constructive and destructive interference. Now last, what I'm going to do is with incoherent waves. What about if light from S1 and S2 are incoherent? The last part is, what about light from S1 and S2 are incoherent? So first I would like to define it again, redefine it. I said light from S1 and S2 are said to be incoherent. If phi, that is phase difference, phi or phase difference changes with times. If a phase difference changes with time, then I'm going to find average phase difference. Right? So phase difference is not constant. Phase difference is changing with times. So now I'll bring that equations. That is I is equal to 4 I naught cos square. So this is changing with time. Phi, that is changing with times. So if a phi is changing with time, then I is also changing with time. So therefore we would like to find out average intensities, right? Right? So therefore, what about average intensity? This is going to be I naught cos, this is average intensity. This is going to become, and then again I will write here, this is equal to, this is constant, cos square 5 by 2. And what is the value of, what is the average of cos 2? This value is equal to half. Alright? If this value is half, alright, then intensity is going to be, average intensity is going to be alright. So intensity you are going to get this. This is very, very important. So look at here. So look at here. This is going to be, this is not going to be an interference. Alright? This is what we call this not interference. Why? Because when we talk about interference, it has to be either constructive or destructive. So this is what we call as an average intensity. So you get average intensity. You get average intensity of light, and I say that you don't get interference patterns. You don't get interference patterns. So maybe in an example they may ask, why two incoherent lights doesn't give you interference. This is the reason. Alright. In case of interference, either you get dark, either you get constructive, or you get destructive. In this case, you are neither getting constructive nor you are getting destructive. You get some average intensity. So this is all about interference. Alright, so I have done with interference in terms of path difference. I have done in terms of phase difference, and also I have done when the two waves are incoherent, no interference pattern will be false. Okay, thank you.